Now the problems on linearity. So determine whether the following systems are linear or not. Determine whether the following systems are linear or not. So in that first problem is yn is equal to n into x of n. So in that there are also three steps to find whether the system is linear or not. So the step 1 is apply 0 input and check the output. If the output is 0, then system is initially relaxed, otherwise system is initially non-relaxed. Then step 2 is apply individual input to the system and note down corresponding output. Then add all the output, denote this addition by y dash of n, and this is the RHS of the equation. And the step 3 is combine all input, apply it to the system, and then find out output y double dash of n, and this is the LHS of the equation. And step 4 is we have now y dash of n and y double dash of n. If this is equal, then the system is linear, otherwise system is non-linear. So these are the basic steps to find whether the system is linear or not. So here the first problem is yn is equal to n into x of n, and we have to find whether the system is linear or not. So in that step 1, when we write here, when input xn is 0, when input x of n is 0, then output yn is equal to n into 0 is 0. So here system is initially relaxed. Therefore system is initially relaxed. Next step 2 is, now let there are 2 points x1n and x2n. Let or consider there are 2 points x1 of n and x2 of n. Now the given equation of output is yn is equal to n into x of n. That means x of n into x of. So in step 2 we have to apply the individual input to the system, and we have to note down the corresponding output, and then add all the output and denote this by y dash of n. So the function of system is to multiply x of n by n. Now for 2 input x1 of n and x2 of n, corresponding outputs are y1 of n and y2 of n. These two are the outputs for the 2 inputs x1 and x2 of n. Now the next step is, therefore which is equal to n x1 of n and now we have to add these output to get y dash of n. We write here add these two output to get y dash of n. Therefore y dash of n is equal to y1n plus y2 of n, which is equal to n x1 of n plus n x2 of n. Therefore y dash n is equal to n is common, it is x1n plus x2 of n. This is our equation number 1. Now the next is step 3. Now we have to combine all input and then apply it to the system, and we have to find out the y double dash of n. Now next is step 3. Step 3 is add inputs. Now add input x1 of n and x2 of n, and then pass it through the system. Therefore x1 of n plus x2 of n which is equal to t of x1n plus so we know that the function of the system is to multiply input by n. We write here, we know that function of system is to multiply input by n. So here x1 of n plus x2 of n acts as one input to the system. So corresponding output is y double dash of n is equal to n into x1n plus x2 of n. Now this is our equation number 2. Now the next step is we have to compare both equation 1 and 2. Compare equation 1 and 2. So since from this equation we can get y dash of n is equal to y double dash of n. So system is, therefore system is linear. So the system is linear. Now the next problem is second one. Find whether the system is linear or not. So it is t into x of n equal to e raised to xn. Now we can write the given equation like yn is equal to e raised to xn. So step 1. Now what is step 1? If input xn is 0, we write here if input x of n is 0, then output yn is equal to e raised to 0 equal to 1. Therefore, system is initially non-relaxed. Even if the system is initially non-relaxed, we have to complete the remaining steps also. Okay, so step 2, here the function of system is to take exponential of x of n. Now let there are two inputs, x1n and x2 of n. Therefore, it is equal to e raised to x1 of n. It is here and not here. Okay, x of n. So x2 of n is y2n. It is equal to e raised to x2 of n. Now we have to add these two input to get y dash of n. So add these output to get y dash of n. Therefore, y dash of n is equal to e raised to x1 of n plus e raised to x2 of n. This is our equation number 1. Now next is step 3. So here first we add the input x1n and x2n and then apply it to the system. So we know that the system produces exponential of the output. Therefore, x1 of n plus x2 of n y dash of n is equal to e raised to x1 of n plus x2 of n. Therefore, y double dash of n is equal to e raised to x1 of n plus x2 of n. Or we can write e raised to x1 of n into e raised to x2 of n. This is equation number 2. Now next is step 4 is compare equation 1 and 2. Compare equation 1 and 2. So y dash of n value is here, which is not equal to y dash of 2. Therefore, system is non-linear. Therefore, the system is not linear. Next problem. Next problem, find whether the system is linear or not. Y of t is equal to cos of x of t. So here step 1, if input x of t is 0, then y of t is equal to cos of 0. So it is equal to 1. So system is not initially non-relaxed. Even if it is non-relaxed, we have to complete the remaining steps also. So step 2 is consider two input x1 of t and x2 of t. Then apply these two input separately to system and observe the function of system is to take cos of input signal. Therefore x1 of t, y1 of t equal to cos of x1 of t, and x2 of t, y2 of t equal to cos of x2 of t. Now we have to add these two output to get y dash of t. Add two output to get y dash of t. Therefore y dash of t is equal to y1t plus y2t. Therefore y dash of t is equal to, this is our equation number 1. Now next is step 3. Step 3 is add two input and pass it through the system. Add two input and pass it through system. Therefore x1 of t plus x2 of t cos of x1 of t plus x2 of t. Therefore y dash of t is equal to cos of x1 of t plus x2 of t. This is our equation number 2. Now using trigonometric identity, cos of a plus b means what? Cos, it is equal to cos a cos b plus sin a sin b. So in this way we apply this equation like to this equation number 2. So equation 2 becomes y dash of t is equal to cos x1t into cos x2t plus sin x1t plus into sin x2 of t. This is equation number 3. Now step 4. What is step 4? Compare equation 1 and 2. So from the equation 1 and 2 we can see that y dash of t is not equal to y double dash of t. Since therefore system is non-linear. System is non-linear. Next problem is find whether the system is casual or non-casual. So next problems are based on casuality of the system. Next problem, determine if system is casual or non-casual. So in that first one, yn is equal to xn plus x of n minus 2. Now what is casual system? Casual system means if output at any instant of the time depend only on the present and past input, but the output does not depend on the future. And anti-casual or non-casual means it is if the output depends on the future input, then it is called as non-casual. So here equation yn equal to xn plus x of n minus 2 is given. So this system is casual system because output depend only on the present input, that is xn, and past, that is x of n minus 2. So we write here it is casual system because output depend only on present input, that is x of n, and past input, that is x of n minus 2. So this system is casual system. Next is second one, t of x of t is equal to e raised to x of t. So we can write this given expression or equation as y of t is equal to e raised to x of t. So this system is casual. This system is casual system since output depend on present input. Since output depend on present input x of n. Now next is yn is equal to x of n plus x of n plus n x of n plus 1. Now here system depends on the future input, that is x of n plus 1. So here output depends on future input. Future input means which one? N into x of n plus 1. So this is non-causal system. So this is non-causal system. Now the next problem is yn is equal to xn plus n into x of n minus 1. Now this is past input, so here system is causal. Here output depend on present and past. It depend on present and past input, so system is causal. So system is causal system. So in this way we can find whether the system is causal or not, or the causality of the system. Next is we have to find the systems are invertible or not, and if it is invertible then we have to find the inverse of the system. Next, which of following systems are invertible? If invertible, find inverse. So first is y of t is equal to x of t minus n. Now here it indicates x of t is delayed by the samples by n samples, so it is invertible system. So we can also design another system in which x of t can be made advanced by the n sample. So the inverse system is z of t is equal to y of t plus n. We write here, it indicates signal x of t is delayed by n samples, so it is invertible system. So it is invertible system. So we can design another system. We write here, we can design another system in which x of t can be made advanced by n samples. Thus, inverse system is z of t is equal to y of t plus n. So we can draw the diagram for this. X of t is applied to the system, then inverse system block, inverse system. So here it is x of t minus n, and this is z of n, which is equal to x of t minus n plus n, which is equal to x of t, that is input. Now next, second problem in this is y of t is equal to x of 2t. So here input is x of t. So this system indicates that output is obtained by compressing the input by factor 2, and there can be another system which will expand input by 2. We write here input is x of t, therefore this system indicates that output is obtained by corresponding input by factor 2, and there can be another system which will expand input by 2. So it is invertible system. So it is invertible system. And inverse system is z of t is equal to y of t by 2. Now we can draw the diagram for this. So x of t is applied to the system, then it is to the inverse system, it is x of 2t, and then it is z of n, which is equal to x of 2t by 2, so it is equal to x of t. Then the next problem in that, third one, yn is equal to n into x of n. So it indicates, we write here, it indicates input xn is multiplied by n. So we design system which will divide input by n. So it is invertible system. It is invertible system, and inverse system is z of n is equal to 1 by n into y of n. And diagram for this is input to the system is x of t, then inverse system, here it is n x of n, and then it is z of n, which is equal to 1 by n into x of n equal to x of n. So in this way we can find whether the systems are invertible or not. So in today's lecture we have seen whether the system is invertible, how to find the invertible system, also how to find the linear or non-linear system, also the causal non-causal system. In the next lecture we will see whether the system is static or unstatic, static or dynamic, or time variant or time invariant. In the next lecture we will start the problems based on the convolution. Okay, problems based on convolution. Thank you.